Hello, here's a quick lesson on Chapter 2-1, Real Numbers and Absolute Value. And this is just going to go through a lot of random things. And so, Chapter 2-1, what we're doing is we're going to define the numbers that you're going to be working with through this unit. Real numbers, and I'm going to show you a nice little layout of a chart describing real numbers. Real numbers follow certain types of real numbers follow certain types of rules. And so this right here is one of the lines separating my chart. So you have the chart divided into two sections, and then within this section, you have three more rectangles. All right. So the innermost rectangle, and this is the most basic form of number that you deal with, is counting numbers. The types of numbers that you've known since you were a child because you counted them on your fingers. So 1, 2, 3, 4, 5, all the way up to however many you want. Counting numbers, or as we define them in this book, natural numbers. The next row is going to be whole numbers, and whole numbers are natural numbers plus 0. The next row is going to be integers. And integers are where you take all whole numbers, but you also count the negative whole numbers as well. So with integers, you have -1, -2, -3, -4, going all the way down to negative however many you want. The last one is rationals, and this is the this and irrational numbers are what make up your entire plane of real numbers. So this entire thing is real numbers, and within rationals you have integers, whole numbers, natural numbers, and within irrationals you have stuff like pi, which is a never-ending decimal. Rationals, let me quick define that because I haven't defined that yet. Rationals are described as being anything you can put into a fraction, basically. Any number that can be put into a fraction with whole numbers on top and on bottom, or integers on top and on bottom. And so numbers that would not be rationals but would rather be irrationals would be, like I said, pi, because it cannot be put into a fraction. It's a never-ending decimal that never repeats. Another one would be the number e, which you don't know about yet. Or if you were to just make up a number, and you would always give a random decimal, there would never be a repeating pattern within the number. So those are examples of irrationals. Counting numbers, like I said, 4, 1, 2, 3, 4. Whole numbers, 0, 1, 2, 3, 4. Integers can be negatives, so -2, -1, 0, 1, 2 are examples. Rational numbers, 1, 1/2, -4/3, or 1.5 are all examples. And then real numbers, an example is any of the above. Any of the above. With ordering numbers, all you have to write on the line for ordering is a number is greater, quote unquote greater, when it is further to the right on the number line. So you have a number line that goes from, it starts, 0's in the middle, it has negatives down here. These are all negative numbers. And then positives are over here. These are all positive numbers. 0's right here in the middle. All right. So that is your number line. And if your number is further to the right on the number line, then it is bigger. But if it's further to the left, then it is smaller. All right. Here's what an opposite is. The opposite of 12 is negative 12. The opposite of negative 2 is positive 2. The pattern is the opposite is just flipping the sign of the number. And so it doesn't matter, even if it's a fraction, all you have to do is flip the sign. The definition of absolute value is the distance. So a distance between two numbers. And in the problems that you see there, if you have the absolute value signs, which are two straight lines going up and down, and they're sort of like parentheses. They're groupings. So in the order of operations, you would figure out what's inside of the absolute value to start. So the absolute value of a problem like 2 minus 5, you would first do the problem on the inside. And 2 minus 5, as you know, is a negative 3. If you take the absolute value of negative 3, what that does is it changes it to a positive 3. So the absolute value of 2 minus 5 is positive 3. Now, we aren't taking opposites here. What we're doing is we're changing anything that happens within these two lines, we're changing it to a positive, no matter what. So even in a problem where you do 4 minus 1, we know that 4 minus 1 is positive 3. All the absolute value does is to check, is it positive? And if it is, then we're set. So this problem is a positive 3. The last thing for absolute value is if you're just taking the absolute value of a number, say negative 12, then the absolute value signs just change whatever's inside to a positive. And so absolute value of negative 12 is 12. So these are magic lines that make anything a positive that are inside of them.